Equations of parabolas. So it says at the top, I'm just going to go through this key information, and there's a graph with some characteristics of parabolas labeled there for you. So a parabola in this chapter is defined to be the set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix. So focus and directrix were two characteristics of parabolas we did not talk about with quadratic functions. So on this graph, you will see the actual parabola itself. You'll see we still have the vertex of a parabola. It's giving that coordinate right here. We still have the axis of symmetry for the parabola, that vertical line. Well, as long as your parabola either opens up or down, the vertical line that would go through the vertex. But then the two new characteristics they're talking about here, the focus is right here, and then the directrix. So the focus is always going to be what you think of to be inside of the parabola, and it's a point. The directrix is a line that would be perpendicular to the axis of symmetry. So this line is horizontal, and it would be outside of the parabola. And then the focus and the directrix are the same distance from the vertex of that parabola. So it says here then another characteristic, the line segment through the focus of a parabola and perpendicular to the axis of symmetry is called the lattice rectum. So that's this short line segment here. It just goes through the focus, and then it has endpoints on the parabola, so it doesn't completely go all the way through. So that's another characteristic. And normally we're just focused on the length, because the length would describe then how wide the parabola opens. And then we have the standard form of the equation of a parabola. So in this chapter, we do not work with y equals ax squared plus bx plus c. The standard form for a parabola in this chapter with vertex hk and axis of symmetry x equals h is y equals a times the quantity x minus h squared plus k. So you have seen this form before in chapter 4. This was called vertex form. So it is a form that we have worked with. And then it says if that a value is greater than 0, remember that means the parabola would open up. So therefore k, the y value of the vertex, would be the minimum value of the related function. If a is less than 0, so therefore your parabola would open down, then the y value of the vertex k would be the maximum value of the related function. So I'm going to stop here. We'll come back to these examples, but I want you to grab the graphic organizer that you picked up. And what you should do first on this graphic organizer, put your name on it, preferably in pen. This graphic organizer, you do not want to misplace, because every formula that we have for our 4 conic sections in this chapter is going on this sheet, and you are allowed to use it on all assessments. If you do not have it with you, though, you don't get to use it. It's not like you're taking your test later. It's just, okay, well, you're taking your test without it. So I've had students in the past write Lifeline on this, because literally there are so many formulas in this chapter, you don't have to memorize any of them. They are all going on this sheet. You are responsible for filling it in and for not losing it. If you lose it, I'll give you another blank one, and you're going to have to find somebody else's to copy everything down again. So do not misplace it. Make sure your name is on it, like I said, preferably in pen. And we'll fill everything out in class. So also, why I'm having you fill this out rather than me just give one to you. If I just gave one to you that was already filled out, at least if you're filling it out yourself, you know where everything is because you're writing it there. There is something where you writing things down helps you remember, so that's why I'm having you fill it out yourself. So I'm just setting aside class time to do that. We are actually filling in all of these first 4 with the parabolas. So what you're going to see in this chapter, we're not only dealing with functions. So a parabola that opens up or down is a function. We are also dealing with parabolas that open sideways, to the left or to the right, which these are not functions. They don't pass the vertical line test. So we're going to fill in these first four. And I'll go slow, but please stop me if I am filling something in too fast, because I want you to be able to write this in so that you have it. So let's just focus on these first two, the top row, the one that opens up or down. So first of all, what you're going to write, or what you're going to want to write down, is the standard form of the parabola. And these both have the same standard form. So it's y equals a times the quantity x minus h squared plus k. The only difference then, and this actually should be the only thing that's different between these two boxes, is the a value, the meaning of it. So if the parabola opens up, the a value is greater than 0, so the a value is positive. And if the parabola opens down, the a value is less than 0, so it's negative. So every other formula we write in will be the same between these two. We're just labeling everything in both. And I'm going to start out by labeling the things that we've already talked about in Chapter 4. So there isn't a point defining this, but what you could do is find where the vertex of your parabola would be, actually for each of them. Vertex is something we've already talked about. So that point, if you want to label it, is your vertex. And has the coordinates h, k. You can label that on both. So everything we label, we're not only labeling what it is, there's a formula for everything. So the vertex has the coordinates h, k. So if you're given the vertex, you already know what h and k are if you're trying to write the equation. Next thing we've already talked about is, and in this case it would just be the y-axis. So if you wanted to even kind of draw a dashed in line over that y-axis for both of them, that would be the axis of symmetry for each of these. So a parabola still has an axis of symmetry. I'm just going to write AOS, but if you're thinking on your organizer you're not going to remember what AOS means, maybe you actually want to write in axis of symmetry. And that, the formula for the axis of symmetry, it's the equation x equals h. And remember from Chapter 4, it is an equation, so it's not just the number h. You have to have the x equals in front of it. Okay, and then we'll fill in the two characteristics we did not talk about in Chapter 4, the focus and the directrix. So the point that is already there for you, that's kind of inside the parabola on both graphs, that is the focus. And there is a formula, it is a point, so there's a formula for the ordered pair. So it has the x coordinate h. So the x coordinate is just your h value. The y coordinate is k plus 1 over 4a. So I'll say that again, and anything up here, if you're looking at it, you can't read what it says, please ask me so you can fill it in correctly. So the x coordinate is h, y coordinate is k plus 1 over 4a. That entire expression is the y coordinate, and I'll label that on the other one as well. Okay, and then the horizontal line that you see that is drawn in underneath the parabola that opens up and then above the parabola that opens down, that is called the directrix. So it's D-I-R-E-C-T-R-I-X, directrix. And that line also has an equation. It's the equation y equals k minus 1 over 4a. K minus 1 over 4a, and I'll label that on the other one as well. There's one last thing, but if anybody's still writing stuff in, so the whole idea here is, I might actually just draw a box around the standard form to differentiate here. The whole idea is if you already have the equation of a parabola, you should be able to identify what your a value, h value, and k values are, so that you can use these formulas to find all of your characteristics to graph it. Or vice versa, if you have a graph or you know what the focus is, what the directrix is, etc., you should be able to use those values to identify A, H, and K so you can write your equation. So everything between the equation and the formulas, it's all in relation to the A, H, and K values. The last thing, and like I said, this was not actually drawn in, so I'm going to have you draw it in, is if you draw a horizontal line segment through the focus with the endpoints on the parabola, so you're drawing in that line segment that's called the latus rectum. And I'm just going to label what that is. I'm actually going to write in the margin, because for all 4 of these, we have the same formula for the latus rectum. So I'm going to label it on here and then put the formula in the margin that applies to all 4. And the formula that we have, again, really what you'd be concerned with is the length of that segment. And the length of it will always be the absolute value of 1 over a units long. So if you know your a value, you take 1 over a, take the absolute value. In case a is negative, the length would be positive then. And it's that many units long. And again, that would kind of show or determine, if you were just given the length, the width of that opening for the parabola. Since a helps determine how wide or narrow a parabola actually is. Okay, so we have the other 2 to fill in, and these, the left and right ones, will also have the same formulas between the 2 of them. The formulas will be different, though, from what's up here. So are there any questions before we move on what any of these formulas say? I want to make sure on your sheets you have them written in correctly. Okay. Am I okay to move this? Okay. So then, for the ones that open sideways, these have a different standard form. So it's the standard form is actually, it's kind of flipped from what's up here. So it's x equals, and then it's a times the quantity y minus k squared plus h. Yep. So x equals a times the quantity y minus k squared plus h. So notice not only did the x and the y switch, the h and the k switched as well. Okay, and the difference, if your parabola opens to the right, like in the first box, that means the a value is positive. And if it opens to the left, the a value is negative. So that's the only difference between the two is the a value. Otherwise, all formulas I write down between those two will be the same. We're just labeling it on both. Okay, and we're going to start with the vertex again. If you just want to label where that would be. The vertex is still the ordered pair HK. So no matter which direction your parabola opens, the vertex will always be the ordered pair HK. The axis of symmetry for these is now going to be a horizontal line. So on this particular, or on these particular graphs, the axis of symmetry is actually the x-axis. But now since the parabolas are opening horizontally, the axis of symmetry is also a horizontal line. So I'll just label that here. So this line is the AOS, axis of symmetry, and that has the equation y equals k. So AOS is y equals k. Then we'll label the focus for each one. So those points that are on the insides of the parabola. And I'm actually going to just draw an arrow to both and then kind of label them both in the middle here. So these are the focus of each parabola. And so the ordered pair for the focus for a sideways parabola is the x-coordinate now has an expression you have to find. So the x-coordinate is the formula h plus 1 over 4a. The y-coordinate is just k. So x is h plus 1 over 4a. Y-coordinate is k for the focus. And then I'll label the directrix for both. So the vertical lines that you see that are on the outsides of the parabolas, that is your directrix. And that has the equation x equals h minus 1 over 4a. So x equals h minus 1 over 4a. And then the last thing would be, we still have that formula that applies for the length of the lattice rectum, but if you just want to draw that in, it would now be a vertical line segment through the focus, still connecting, the endpoints would be on the parabola. You can draw it in and then label it. All right, any questions on what any of those formulas say, if there's something you didn't quite get down? Okay, so make sure that you just always have this with you. Probably every class period in this chapter, you will just want this out because we're going to be using these formulas to either identify the equation, find AHK, use the formulas so that we can graph. We'll be graphing tomorrow, or vice versa. If we're given information, use what we're given to find AH and K to actually write the equation. So either way, you're going to want this out, and then as we move through all 4 conic sections, we'll fill in the rest: circles, ellipses, hyperbolas. Okay, are we good if I move this and go through the 2 examples we have? Okay. So I just have 2 examples, and then the back side is actually, I just have 4 questions for your assignment, so we might even get through these and you have enough time to finish all 4 of those examples while you're here. All I have for today, so because I know it takes time to fill in the graphic organizer, I've actually split parabolas into 3 lessons. Today we're just taking an equation that's called to be in general form and writing it in standard form. Tomorrow we'll be graphing. Wednesday we'll be given information about a parabola, and we'll have to find the equation from the information we're given. So what it says above the first example, an equation that is in one of these 2 forms. So the form that we were more familiar with from chapter 4, the y equals ax squared plus bx plus c, or this is what it would look like if you had x equals for the sideways parabolas. That is now called the general form. So if an equation is given to in general form, we can write it in standard form. And then what we've already talked about is the shape of the parabola, distance between the focus and the directrix. They all depend on A. So how to get these into standard form. So if we look at example 1, I know the 1 was cut off by the hole punch here. It says write y plus 2x squared plus 32 equals negative 16x minus 1. Write that in standard form. And then identify the vertex, the axis of symmetry, and the direction of the opening of the parabola. So first of all, because when you have a parabola, so what we had just put on our sheet, our standard form could be the y equals, or it could be the x equals. So what you first want to identify is which one you're going to have, and how to tell is you look for which variable is not being squared. So we have y, we have x squared. So if we have x squared, that means we're going to have the first form, the y equals a times the quantity x minus h squared plus k. So identify which variable is not being squared first. I know there is still an x here, but we have the x squared. And then what you want to do is get that variable alone. So we want to get y alone in our first step. So I am going to subtract 32 from each side and subtract the 2x squared from each side. So we'll have y equals, and then I'm going to write this in the general form, so I'm going to write the negative 2x squared first, followed by the minus 16x. And then we have a minus 1, and we're subtracting 32, so we have minus 33. Okay, from here, so you've actually done this before. We did this in chapter 4, except the directions might have stated to write the equation in vertex form, but it's that same process. So what we want to do from here is group together the x terms. So we're leaving the minus 33 off on its own. And in order to get, our goal is to get a quantity squared. In order to get a quantity squared, we're going to have to complete the square and factor it. When you factor a perfect square trinomial, that's when you get a quantity squared like that. So in order to complete the square, if you have a number other than 1 in front of the x squared, you have to factor that out of just these two terms. So I'm going to factor out the negative 2 from just the x terms, not from the minus 33. So I have y equals negative 2 in front, and then I would have a positive x squared and a positive 8x. And then I'm going to put a plus blank right away because I'm going to be completing the square. And then I have a minus 33 on the outside. And remember to keep your equation balanced. If I'm adding something to this side, I'm also going to have to subtract it from the same side, because I want to keep the y by itself. So if I'm adding something here, I have to keep it balanced by also subtracting it from the same side. All right, so I first need to complete the square. So you're looking for the c value that would make this a perfect square trinomial. Anyone remember how to find that value? There was a formula for it. Cora? Yes, it is your b value divided by 2 squared. So in this case, it would be, it would be 8 divided by 2 squared. So 4 squared, so it'd be 16. And we'll be completing the square a lot this chapter. For every conic section, to get it into standard form, you're going to have to complete the square at least once. So we'll be doing it a lot. So now, if I have a 16 here, I don't just put 16 in this blank as well, because this 16 is being affected by the negative 2 in front. So this is really representing negative 32. So I would put a negative 32 here, because it's negative 2 times 16. And now that negative 32 is being subtracted, so it'll really be added at the end. Okay, so now, once you've completed the square, if you want to make a note too, this came from the negative 2 times 16. If you want to make a note just so you know where it came from. Then from here, you now factor this. And it's a perfect square trinomial, so it should be the same quantity squared. Anyone know what that quantity will be that's being squared when it's factored? What did you say? X plus 4, yes. So x plus 4 quantity squared. I'm going to explain this. There was a shortcut to find this. I'm going to explain a few different ways to get this if you don't remember. And then on the outside, you just simplify negative 33. This changed to plus 32 is just minus 1. So remember to factor. First of all, this is a trinomial. So if you can't remember the shortcut, just set up a diamond and say I'm multiplying to 16, adding to 8. And these two numbers should be the same. If it's a perfect square trinomial, it ends up being 4 and 4. So it's x plus 4, or x plus 4 quantity squared. Another way to get here is this plus 4, whatever number is here, will always be whatever your b divided by 2 was. So half of positive 8 is positive 4. It's also the square root of 16. It's the square root of this number. So there's a few different shortcuts, or a couple shortcuts to get here, or just make a diamond if you don't remember. Okay, however you get there, you have to be able to factor it to complete the square. Okay, so this is your standard form. The question, though, then says to identify the vertex, axis of symmetry, and direction of the opening. So this is where the formulas we put on our sheet could help. If you look at this equation, what is the a value? A is negative 2. What is h? H is negative 4, yes. So because the formula is x minus h quantity squared, h is really the opposite of positive 4, because plus 4 is really x minus negative 4. So h is negative 4, what's k? I heard negative 1. Okay, the vertex is the ordered pair hk. So our vertex is negative 4, negative 1. The axis of symmetry for a parabola that opens up or down, or the parabola that has the standard form with y equals, is the equation x equals h. So if h is negative 4, the axis of symmetry is x equals negative 4. And then we're saying which way it opens. What direction does this one open? Down. How do you know it's down? Yeah, a is less than 0, a is negative 2, and we know it has to be up or down based on the standard form. So it would be down. Okay, so like I said, this process we did before, it's phrased a little bit differently. It's going back. We did this in chapter 4, so it was a little bit ago. You'll be going through this process a lot in this chapter. Okay, then for number 2, I want to go through this one with you also because it does work out a little bit differently. First of all, looking at the equation that we have, is our standard form going to be the same one that we had before with y equals, or will it be with x equals? Which variable do we want to get alone first? We're going to get the x alone because we have a y squared. So I'm going to add y squared to both sides first. I know there's a 2 in front of the x. Just hold off on dividing by 2. So I have 2x equals, and then I would have positive y squared plus 4y plus 10. I could divide by 2 right away. I'm going to wait. So if there's a number multiplied in front of that variable, you can wait and divide at the end, which is what I'm going to do, so that I don't have to deal with a 1/2 in front of the y squared right now. So from here, just like we did above, I'm grouping together the y terms. I leave the plus 10 alone. What's nice with this one is I just have a 1 in front of the y squared, so I don't have to do anything to factor anything out. So I'm just going to get ready to complete the square. So I have 2x equals y squared plus 4y plus some number. And then I have plus 10. And then whatever number I add here, I'm going to have to subtract on the outside. So what number would I be adding here to complete the square? 4, yes. So I'd have 4 divided by 2 squared, which is 2 squared, which is 4. And then I don't have any number in front to multiply it by, so if I'm adding 4 here, I'm subtracting 4 on the outside. So I have 2x equals y squared plus 4y plus 4. What will that be in factored form? Yep, y plus 2 quantity squared, and then 10 minus 4 would be a plus 6. So now the last thing I have to do then, and right now there is a 1 in front of that y plus 2 quantity squared, is now I can divide everything by 2 to get the x alone. So I divide this term by 2 and the 6 by 2. When I do that, and take note, I am dividing the 1 that's in front by 2. I am not dividing this 2 that's in the parentheses by 2. This 2 doesn't get touched. So I just have a 1/2 in front. I still have y plus 2 quantity squared. And then 6 divided by 2 leaves me with a plus 3 at the end. Okay, so that's my equation in standard form. I then have to identify what's the vertex, what's the axis of symmetry, and then which way does it open. So for this equation, and look at your sheet, be careful with this. What's your A value? 1/2. What is H? H is not 2. H is not -2. H is 3. So look at your equation closely. When it's x equals, K is the value that's inside. H is on the outside. So always double check with the formulas. That's a common, I know it's different. I didn't make the formulas, but that's an easy mistake. So H is actually 3. K then is the opposite of what you see in the parentheses. K is -2. So double check, triple check that you're using the formulas correctly. So your vertex is still HK. So it's 3, -2. Your axis of symmetry is the equation y equals k. So it's y equals -2. And then here our A value is positive. Which way does this one open? Doesn't open up. It opens to the right, yes. So if it's x equals, it's opening sideways. And you have your sheet to look at. If A is positive, it's opening to the right. If you even want to make that note on here, that this one, I don't know why this gets mixed up. This one is opening to the right. This one is opening to the left. So if that helps you to write those in, that might seem silly, but it's easily confused for some reason. So if that helps, you can write that in. I do also want to make a note. You should not be adding anything to your graphic organizer that I don't either tell you to add or approve that you're adding to it. Because if somebody's adding something, everybody would have to add it to be fair. So I do check your graphic organizers while you're taking quizzes and tests. If there's extra stuff, I take it. That would be cheating then. So do not just add things to your graphic organizer that we're not adding in class. Okay? Any questions on these examples?